With software installed, devices connected, and the logic engine ready, it's time to build the actual screens your users will see and touch. By the end of this session, you will have built this exact interface from scratch. We are going to construct a working application featuring a top navigation bar, a styled floating central card, and text that updates interactively when tapped. Before we write the first line of code, ensure you have a completely empty Flutter project open in your editor and your phone or emulator is connected and running. Every massive, highly complex mobile application in the world is built from the exact same visual blocks we are about to use. Learning how to place and style these specific components is the mandatory first step to engineering any screen you can imagine. To do this, we must understand Flutter's core rule. Look at this diagram. In Flutter, everything on the screen is a widget: the navigation bar, the text, the button. You construct interfaces simply by selecting these pre-engineered digital Lego bricks and snapping them together. Notice the difference between the two blocks shown here. On the left are visible widgets, like buttons and text, which your user interacts with. On the right are layout widgets, invisible, transparent blocks sitting behind the scenes to control exactly where visible widgets go. To get a single piece of text onto a screen, we nest 3 widgets. First, the Material App widget sets up the app structure. Second, the Scaffold widget acts as the blank canvas. Finally, the Text widget holds our words. You never have to calculate pixel coordinates or draw shapes from scratch. Simply declare the pre-engineered components you want, and Flutter handles the rendering. Here is our first type of component, the Statless widget. Think of it like a printed paper poster locked to a wall. Once rendered, it is permanently frozen. If the data inside changes, the screen will completely ignore you. Now look at this digital scoreboard interface. This is a stateful widget. Instead of a locked poster, it has a built-in active memory called its state. When new data arrives, this widget can instantly update its screen to reflect the new numbers. To trigger an update, we use setState. It alerts the Flutter engine to redraw the screen. And if you need memory later, simply click the editor's lightbulb icon to convert a static widget to a stateful one. A simple static picture becomes a functional application the moment you begin controlling and manipulating this internal memory. Now let's build the physical structure of our app using the Scaffold widget. It automatically calculates the safe areas of your specific device, protecting your layout from overlapping the camera notch or system menus. At the top is the app bar, your main navigation signboard. It has 3 zones: the leading zone for menus, the center title zone, and the action zone for tools like search or notifications. By plugging an app bar directly into your scaffold, you get professional, platform-standard navigation immediately, without writing a single line of mathematical layout code. Next, we need to let the user interact with our screen. Flutter provides the solid, elevated button for main actions, the flat text button for secondary choices, and the icon button for universal symbols. Every button needs on-pressed, the electrical wiring connecting a physical tap to your logic. Empty brackets sever this connection, disabling the button. To make it work, write instructions inside, placing data changes directly into setState. When the user physically taps that button, on-pressed fires. setState rings the alarm, and our stateful scoreboard updates its memory to show the new result. To keep layouts organized, we use the Container widget. Inside, padding applies internal pressure, pushing text away from the walls. Outside, margin forms an external barrier, pushing neighboring widgets away so they don't crash into each other. Be careful. When using a box decoration for rounded corners or shadows, you must place your color property inside that decoration. If you leave the color on the outside, the application will immediately crash and show a red error screen. A premium user experience relies on these invisible metrics. Consistent padding and precise margins make your application feel professional before you add any custom graphics. Let's test everything we've built. Look at the live device screen here. On the left is the initial interface. When we press the booking button, the screen instantly redraws to display the updated success text on the right. We achieved this by combining 3 distinct systems: the scaffold framework to hold the structure, a container to calculate the spacing, and our stateful logic wire to handle the interactivity. Right now, we have successfully managed a single item in the center of our screen, but a real application requires dozens of elements stacked and aligned perfectly. Next, we will break out of the center and learn how to construct complex vertical layouts using columns.